Hello again, Year 12, and welcome to our 7th video here on series and sequences. In our last video, we looked at the sum of an AP, and today we're going to look at the sum of a GP, geometric series. We're going to call it a series because we're adding the terms together. So, let's have a look here. Consider this sum to n terms of a GP. So we've got term 1 plus term 2 plus term 3 and so on to term n minus 1 and term n, which would also be a plus ar squared and so on, till we get to ar to the n minus 2 and ar to the n minus 1, which is, you might remember, our expression for the nth term of a GP. Now, if I multiply both sides of this equation by r, I'll have r by the sum to n terms on the left. Then I'm going to have ar plus ar squared plus ar cubed and so on. Now if I multiply this by r, the power of r will increase by 1, so that'll be ar to the n minus 1 and ar to the n. I'm just going to tidy that up a little bit here. And we've got r times the sum to n terms, ar plus ar squared and so on. And if I shuffle that along, we can sort of match these terms up. Okay, I'm missing the a here at the beginning, but these will match up, these will match up. Somewhere along the line, these will match up, these will match up. Remember, this is the third term multiplied by r, and the third last, and this is the second last. And then at the end, I end up with this extra term here that doesn't match. So I have an a at the beginning of the sum to n that doesn't pair up with anything, and an ar to the n at the end of that expression for r times the sum to n that doesn't pair up with anything. Now, I'm going to subtract the sum to n terms from r times the sum to n terms. And we'll notice these terms cancel each other out, and these, and these, and these. And what I'm left with is ar to the n minus a. Okay, this is looking better. From here we're going to factorise. We're going to take a sum to n terms out of the left-hand side and an a out of the right-hand side. And then I'm going to divide both sides by r minus 1. And I'm left with an expression for the sum to n terms in terms of, expressed in terms of a, r, and n. That's all. So here is a formula for the sum to n terms for a GP. That's a fairly tricky, I think this part here, these two steps here are reasonably tricky to remember. However, you don't need to remember the derivation of it. This formula here, again, you don't even need to remember that. It's on your reference sheet. But the sum to n terms of a GP, a outside of r to the power of n minus 1 over r minus 1. In the instance that r is a small number, r is between 0 and 1, let's stick with a positive number, but positive small number between 0 and 1, then r minus 1 will be negative, and r to the power of n, a small number raised to some power, gets smaller. So when I subtract 1 from that, it will be negative as well. So the top and bottom will be negative. The negative signs will cancel out. It just turns out to be a little bit neater. Multiply top and bottom by negative 1, and we get this expression here. So if r is small, you're better off using the bottom expression. If r is larger than 1, you're better off using the top expression. Either will work in both situations. It's just a little bit messier in terms of negative signs. So there are those formulas, and you know what comes next. We've got an example. So we're going to evaluate the sum to 5 terms for each of these GPs. First up, 3, 6, 12. We can see a equals 3, r equals 2. So the sum to 5 terms is a outside of r to the power of n minus 1 over r minus 1. So 2 to the power of 5 is 32 minus 1 is 31. 3 31s are 93. 2 minus 1 is just 1, so it should just be 93. There we go. Again, better than working out, calculating each of those individual 5 terms and adding them together. Here's another example, 4, 3, 9 over 4, and so on. We know it's GP. First term is a equals 4. Now the common ratio will be 3 over 4, or if you like, 9 over 4 over 3. But that's 3/4. We could use 0.75. If you can use a calculator, that might be easier, but we can get away with fractions. So a equals 4 and r equals 3/4. I'm going to use the different formula this time, right? The alternative there, because r is a small number. It's less than 1. So this time I'm going to say that the sum to 5 terms is a times 1 minus r to the n over 1 minus r. And when I evaluate that out, 781 on 64. There we go. It's the sum to 5 terms of both of those GPs, okay, using each of the two formulas. That's it for today. Just a reminder, we can find the sum to n terms of a GP using either of these formulas, and we'll probably select those formulas depending on whether r is large or small. Rightio, that's all. If you've got any questions, make sure you ask me in class. Otherwise, next video is going to be the limiting sum of a GP. Rightio, I'll see you then. Bye.